Hey everyone, welcome back to another video by Prep Academy. This is Nimi Hanna James. We have been already started our math preparations for board exams and dealt with some of the important chapters, vector algebra, three-dimensional geometry, and we have started the calculus. We discussed differential calculus in our last video. So in this video, we will be looking forward to integral calculus. Most of the students say that it's so confusing and they don't know how to approach the chapter, so we will be dealing everything for that. Okay, and this is going to be your easiest chapter for your exams. Okay, so integration. So if you have a good basic in differentiation, then integration can you can easily connect with integration. Integration is just the reverse process of differentiation. Okay, integration is just a reverse process of differentiation. That is, if you have a function sin x, that is, we know that the differential of sin x is cos x. Okay, so then we are taking the reverse process. We are in this type, sin x is the question, sin x is function we are differentiating, and we have the answer. So this is like, so this means the integral of cos x is equal to cos x dx is equal to sin x. This dx actually means that we are integrating this cos x, the function, integrating the cos x function with respect to x. So while doing this d by dx, differentiating, there also there was a dx. That meant we are differentiating with respect to x. Here it means that we are integrating with respect to x. So sin x, the integral of cos x dx is equal to sin x. So similarly, if you have, we know that the differential of tan x, the differential of tan x is sec square x. Similarly, the integral of sec square x is equal to tan x. Sec square x dx. Okay, you have to always write sec integral and dx there. So integral sec square x dx is equal to tan x. So these are all the basic standard integral values that you must know. Only if you know this, you can proceed with the chapter. If you know all of these formulas by your heart, then this is going to be very easy. Okay, otherwise it might be some little bit hard. So if you have not yet studied this, learn it right now. Okay, all of these values for x raised to n, 1 by x, e raised to x, sin x, cos x, sec square x. So all of these values, see, look here, sec x tan x, integral of sec x tan x. Integral of sec x tan x, we know. So when we see such a question, we think that, okay, do I know any value whose differential is sec x tan x? Yes, the differential of sec x is sec x tan x. So the integral of sec x tan x is sec x. So it's just the reverse process. Okay, that's it is very simple as that. Okay, so all of these values for sine inverse x and cos inverse x and all of these values you have to learn. And some trigonometric identities also. This you have already learned in your class 11. So in class 11 you have might have learned cos 2x is equal to 1 minus 2 sine square x. So from this formula we can derive that sine square x is equal to 1 minus cos 2x by 2. Also cos 2x has another formula, which is cos 2x is equal to 2 cos square x minus 1. From this equation we arrived at this solution that cos square x is equal to cos 2x plus 1 by 2. So this is our second one right here, and this is the third one. So you might have not learned this like this. You might or sine 3x, cos 3x. So these are all the expansions that we might be able to use in this chapter. Okay, in solving problems using trigonometric identities. Okay, so all of these trigonometric identities also you have to know, and this half angle properties too. So cos square x by 2 and 2 sine square x by 2, these are all very important and which will be very much useful. Sin x, these are all okay, and this also in very much important. So all of these formulas you have to know, and it doesn't end there actually. You have to know some of the other special integrals also. So for example, I'll give you an example. So it is integral 1 by x squared plus 4 dx. So when we see such a question, we have to think, okay, do I know any function whose differential is 1 by x squared plus 4? So not directly. So that's why we have these 9 special function integrals. If you know these 9 special functions, so we have to, the question might not be directly in this form. So in this case, in the question, we can write this 4 is 2 square, right? So it is 1 by integral 1 by x square plus 2 square dx. Sorry, this one is not there. Okay, integral 1 by x square plus 2 square dx. So when we see here, when we check the list of equations here, yeah, right here in the third equation, it is integral dx by x square plus a square. It's the same, right? But in the place of a, we have 2. A is equal to 2. So the answer is given there. We already know the answer if we know these set of equations. So this is the answer. No need of any other process. No need of doing any other complex machines or whatever. It's just the answer. Okay, we have the answer, just substitute the answer. So here we have a is equal to 2, so it is 1 by 2 tan inverse x by 2 plus c. Okay, so this is the answer for this question. So similarly, you can solve many questions like see, all of these have a standard format, so you just have to know these equations and solve them. Okay, the first step to ace this chapter is to learn all the formulas. There are a lot of formulas and there are different methods of substitution. So first you have to learn these formats. And now we moving on to discuss the different methods of integration. So in some cases, for example, if we want to know the differential of sec square x, as we have said already, we know that okay, tan x has its differential as sec square x, so integral of sec square x is tan x. It was very direct. But in some questions, we don't get to know what is it. So there we have to use, for different types of questions, we will be having to use different methods. There is integration by substitution method, and then integration by partial fractions, integration by parts, and some other options also. So all of these. Okay. So here the first method we will be discussing is integration by substitution. This is a very important method. Okay, so it's just mean that if we have a function and its derivative together in a equation, so that is integral of sin x by cos x dx. Okay, we are going to integrate. So do we know, so what is sin x by cos x? It is tan x. Do we know anything which is differential is tan x? We don't yet. So integral of sin x by cos x we have to solve. So when we look at it, we have cos x and sin x. So if we take, I am substituting, so the name itself suggests that it is integration by substitution. So I am going to substitute, okay, substitute cos x is equal to t, some value t. Okay, substitute cos x is equal to t. And here, what we want to do is to now differentiate. After substituting, the second step is to differentiate. So differential of cos x is minus sin x dx. Differential of cos x with respect to x, it is minus sin x dx, which is equal to differential of t is dt. So that's how we get it. And when we look here, we have sin x dx. So we have an additional minus sign here. So we just throw it on the other side. So sin x dx is equal to dt, minus dt. Okay. Now we have cos x is equal to t and sin x dx is equal to minus dt. We're going to substitute in here. That is integral. Sin x dx is what? Minus dt. So we substituted that by cos x is what? It is t. Okay. Now we can take minus outside of the integral. As we take minus outside of differential, we can take minus outside of the integral also. So minus integral of dt by t. So what is the integral of 1 by t? Let's check the formats. See here we have, yeah, Integral of 1 by x dx is log mod x plus c. So integral of 1 by t dt is log mod t plus c. Okay, and we have to substitute it back. We shouldn't keep it like t. Our question, initially the question was in the terms of x. So we have to back substitute it. So log mod, what was t? It is cos x. So log mod cos x plus c. That is the integral of sin x by cos x dx. Okay, so this is the method of substitution. When we search for someone, okay, we just search that if its differential is also present there, we can use the substitution method. Okay, so this is how substitution method is done. So we just substitute one of the term as cos x is equal to t and differentiate it and make it as suitable for the question and just substitute and differentiate. So after doing the substitution method, we got a form that we already know whose integral is. That's what we are simplifying the question. Okay, these are all the steps for simplifying the question. So this method of substitution is very important, which can be used in the middle of a big problem. Okay, integration by partial fraction is another method. So for functions of this form, of these 5 forms, so for all of these 5 forms there are different methods. So for example, if the one of the equation, if x by x plus 1 into x minus 1. Okay, so this integration by partial fraction is used for problems with its numerator is a linear function and its denominator it is x plus 1, that is it is the linear factors. Okay, they are some linear factors. So such is called is used for that. Okay, and now x by x plus 1 into this we are going to solve. So when we check on this, x by x plus 1 into x minus 1. So px plus q by x minus a into x minus b is equal to a by x minus a plus b by x minus b. So that's what we're going to do. We don't know, we want to separate this. Our main goal, ultimate goal is to split them into two and then integrate. So we can't write, can we write x by x plus 1 into x by x minus 1? Can we write it? No, it is very wrong. It's a blunder. If this is right, we multiply the numerators, right? It is x square. If it was x square, then we could have done that, but here we can't do that. So this is very wrong. So we want to just split the equation. Okay, so that's what we're doing here. So this is the format for this type of question. So a by a is any constant. Okay, a by x plus 1, that is the first factor. Here the first factor was x minus a, that's why we wrote x plus 1, plus b by x minus 1, that is here it is the second factor. So we split the equation. Now what we're going to do is just we want to find a and b, the value of a and b. So if I'm doing this, if I'm taking the LCM of these right side value is x plus 1 into x minus 1, correct? I just took the LCM. It is just multiplied the denominators, and what we do for the numerators, we cross multiply, correct? We cross multiply. So a into x minus 1 plus b into x plus 1, and then we want to solve it. So looking like this, the denominator of this side and the right side are equal. So if the denominators are equal, then the numerators must be equal. That means x is equal to a into x minus 1 plus b into x plus 1. Okay, so x is equal to ax minus a plus bx plus b. Okay, so we want to find the coefficients of a, a and b. So equating the coefficients. So here in the left side, the coefficient of x is 1, and on the right side the coefficient of x is a plus b. So 1 is equal to a plus b, right? Equating the coefficients of x and the constants. Okay, so 1 is equal to a plus b. And here also when we check the constants, on the left side what is the constant? X is x plus 0. So x0 is the constant term, and on the right side the constant terms are minus a plus b. Okay, so we got a plus b equal to 1 and minus a plus b. So we got two equations in two variables, that is a, b. So we can solve it using any method that you know you have studied in class 10, elimination method or substitution method or whatever. So elimination will be more comfortable. Uh, so we just add these two equations. So a and minus a will get cancelled. So 2b is equal to 1. That means b is equal to 1 by 2. Okay, it is that simple. And now substitute this 1 by 2 in any of these equations. So b is equal to 1 by 2 means a plus b is equal to 1. So 1 by 2 plus 1 by 2. So that is a is equal to a is equal to 1 by 2. A is also is equal to 1 by 2. Okay, so we got the values of a and b now just by solving. Okay, so the next step we have to do is substitute these values of a and b right here. Okay, I'm going to substitute. So this was our question. So a, in the place of a, I want to write 1 by 2. So 1 by 2 into 1 by x plus 1. Right? It is a by 1 by x plus 1. That a by x plus 1 means a into 1 by x plus 1. That is a into 1 by x plus 1 plus b into b is 1 by 2 into 1 by x plus 1. Now we will be integrating. So the integral of this means integral of this. So this now is very simple. Now we take 1 by 2 outside of this, that is 1 by 2, and x plus 1, for x plus 1 the integral of x plus 1 is just as we discussed. We can use the substitution or whatever it is, log x plus 1 plus 1 by 2 into it is log x minus 1. Okay, so this is the answer. So this is the method of partial fraction. I've just discussed a one question. There are so many questions in your textbook. Please do practice all of that questions. The more you practice, the more you be a pro in this. Okay, so I'll just repeat what is the concept. So for equations of this type, for linear equations where we have different types of factors in the denominator, so in these type of questions we will be using the partial fraction method. For different types of, so this was we just did a question for only one type. Okay, so for 2, 3, 4 and 5 types are there. If x minus a the whole square is there, it's x minus a plus x minus a the whole square. Then x minus a, x minus b, x minus c is there. We factor them into 3. A by x minus a plus b by x minus b plus c by x minus c. And this last one you have to know that x square plus bx plus c. This is a quadratic function which can't be factorized further. So if we check all of these above 4 types, all of them in the denominators, they were all linear factors. All the powers of x were only 1. Here, you might think, why can't we do that? We can't do that. For example, x square plus 1. If this is a quadratic equation, what is the solution? Does it have a real solution? The solution for x square plus 1 is x square minus 1. X is equal to root of minus 1. Is this a real number? It is a complex number, correct? So these type of equation do not have a solution in the real number. So such equation can't be factorized further. So in that cases, we can't factorize this x square plus 1 into anything else. X square plus 1 is x square plus 1. That's it. That is the lowest it can fall in the real plane. Okay. So it is a by, so for that cases, we use this a by x minus a plus the denominator we keep it at is, and bx plus c will be the numerator. So this formats you have to know. If you know, then find a and b, substitute and solve. That's it. Okay. And then we have the integration by parts, which is a very useful method. This we use, we have these differential calculus, we have the product rule. So in integration we have the integration by parts. That is, if we have u and v, we have two functions, they are the product of each other, not each other. That is, u and v are producted. Okay, that is u into v. So for u into v, the differential, when we have to take u into v, the differential, we had a product rule, right? So here, this is the product rule. This acts as the product rule. It is called the integration by parts. So here u and v, u is the first function and v is the second function. Okay, u is the first function and v is the second function. So this is how we expand. That is first function into, we keep the first function like that, first function into integral of second function minus integral of, we have to open a bracket, differential of first function into integral of second function dx. Okay, so some complex, it might be a little long, but you will get the answer. Okay, it is, if you master it, it will be very easy. So for example, if we want to differentiate this, sorry, find the integral value for integral e raised to x into x dx. Okay, so here you see there is this order for taking the first function. We can't just randomly take, okay, this is first function and this is second function. If we can, but we won't be arriving at any useful conclusions. So if we want to arrive at any conclusion, we have to follow this Eilert rule. That is, this is the priority we have to which function should be first. If we have an inverse trigonometric function, see, I for inverse trigonometric, L for logarithmic, A for algebraic, T for trigonometric, and E for exponential. If we have, if one of the two functions is, one of them is inverse trigonometric, that should be the first function. Okay, so this order should go. So in this equation, this first one here, it is an exponential function, and the second, this x is an algebraic function. According to the Eilert rule, A should come first, E should come then. So we will be arranging this, that is, it is x into e raised to x dx. A is first, that is, A is the first function and e raised to x is the second function. Now just applying this integration by parts rule, that is u into, that is the first function into, okay, integral of second function minus integral of, this is a big integral, then open a bracket, differential of u, that is differential of the first function into integral of second function, and again a dx outside, because for this integral we want a dx. Okay, so x into integral of e raised to x is e raised to x itself minus integral of d by dx of x is 1 into e raised to x dx. Integrating it again, here we have one more integral symbol pending. So x e raised to x minus, in the integral is gone, so it is e raised to x plus c. So x e raised to x minus e raised to x plus c is the answer for this integration. Okay, so this is where we use the integration by parts. And we have these definite integrations, definite integrals and its properties. This is a very important. Okay, most of the questions for your exam will be, there will be definitely one question from this section. Okay, so for definite integral means, earlier we were doing just limits, just integration. Now here we have the limits in the integration. Okay, so we know we have this integral of cos x. Okay, integral of cos x dx, we know that it is sin x plus c, correct? So for definite integral there won't be this plus c. Okay, it is definite, we don't want to have any confusion, there is no plus c, but there will be limit, that is, we are integrating it from 0 to pi by 2, some limit is there. So what we have to do is, we just have to integrate it normally, that is cos x, integral is sin x, and apply this value, that is upper limit. He see f of b, that is the upper limit, that is sin x becomes sin pi by 2 minus lower limit, that is sin 0. Okay, upper limit minus lower limit, sin pi by 2 minus sin 0. Sin pi by 2 is 1 and sin 0 is 0. So the answer is 1. Okay, so this is how we integrate. So for definite integral, the answer will be a number. Okay, so all of these properties that you have to know, of which this King's property is very important. Okay, all of these are important, all of these you should know. The most importantly used is this King's property, that is integral of 0 to f of x dx is equal to integral of 0 to a f of a minus x, without even changing the limit. There is no need to change the limit here, but we change the function from f of x to f of a minus x. Okay, so that's one important. All of these are important. If we have a to b, if we want to integrate a to b, then we can split it somewhere. If a to b, we can split it somewhere. First we can do a to c and then c to b. So it can be done like that. And some remaining properties also there. This Queen's rule and this even and odd. This even and odd is very important. This is so much used everywhere. That is, if we see question for integral minus a to a f of x dx, that is integral minus 1 to 1, integral minus 2 to 2, integral minus 5 to 5, or integral minus pi by 2 pi by 2. That is, if we are dealing with integration limits that are both the same number but of different sign, okay, that is minus a and a, there first thing we have to check is if the function is even or odd. Okay, in a question, if you see the integral limits as minus a and a, then you have to check if the function is even or odd. So the function changes if the function is even or odd. So what is this even function and odd function? If f of minus x is equal to f of x, that is an even function, and f of minus x is equal to minus f of x, it is an odd function. I'll make it clear. If I am taking f of x is equal to sin x, okay, I want to know if this is an even function or odd function. So I'm just taking f of minus x. Okay, I have f of x already. So I just take f of minus x. That is, I just substitute minus x instead of x in here. So sine of minus x, like that. Sine of minus x is minus sine x, that we have learned in 11th standard and all. So sine x is what? F of x. So minus f of x. So that's it. F of minus x, after substituting all these, we got minus f of x. That means from the definition, it is an odd function. So sin x is an odd function. So what about cos x? F of x is equal to cos x. So there also we take f of minus x, that is cos of minus x. Cos of minus x is cos x. That means it is equal to f of x. So f of minus x equal to f of x, then it is an even function, and this is an odd function. Okay, clear? So if the function is an odd function, the integral value is 0. No need to check anything, the integral value is 0. If the function is even, then you can change the limit from minus a to a, you can just change it 0 to a, and it is 2 into integral 0 to a. Okay, got it? Moving on to the next chapter, which is application of integrals. If you know how to integrate functions using all these problems, all these methods in using substitution or partial fractions or parts or whatever, if you know to differentiate it, then you can find the application. That application is that we will be using this integral values to find the area under some curves. If we have a curve like this, okay, and we want to know what is the area under this curve, okay, so this area under the curve is the integral value of this function. Okay, that is, we can take either this kind of a vertical strip or a horizontal strip. Okay, if we are taking a vertical strip, it is dx, that is a very small x value, correct? If we are taking a horizontal strip, it is a dy. Okay, so the area, if we are finding it with respect to x axis, that is dx, then we will be writing the function as y equal to something in the x values. And if we are taking it with respect to y axis, then we will be writing x, that is x equal to something in terms of y, the function in y. So that's how we, and then integrate and substitute this value c of d, the limit, find the definite integral, and that is the answer for the area. Okay, so and these are some of the things that you have to just know. We will be taking vertical strips and horizontal strips. It's very simple that, so we will be discussing in the some problems. So let's do some problems from both of these chapters. Okay, So evaluate the definite integral, integral minus 1 to 1 x mod x dx. So I will not be doing every problem from this chapter since we have a very small time. This is going to be revision. If you are little bit uh, confusing or you know something about this chapter, then you can of course proceed. If you are very fresh to this chapter, please learn the chapter and do some of the problems from the exercises and then do. So we can do some of problems which is some previous year questions. These are some previous year questions, important questions. Okay, so first question is evaluate the definite integral, integral minus 1 to 1 x mod x dx. Okay, so see here it is the integral which is the limits are minus 1 to 1. That is it has the lower limit and upper limit are the same number but different sign. So what did I say about integrating such functions? The first thing we have to look for is if it is an even or odd function. Okay, so here in this question we have the f of x is x mod x, correct? So we are checking if it is an odd or even. So take f of minus x. So f of minus x means substitute minus x wherever we see x. So minus x mod minus x. So minus x into, when we take the mod of minus x outside, it becomes x. Okay, so mod of minus x is equal to mod x. So which means it is minus f of x. So f of minus x is equal to minus f of x. That means it is an odd function. And what did I say about odd functions integral value? 0. Okay, so the option is 0. So you don't have to think of anything else. If the function is odd, it is 0. Okay, so 0 is the answer. Then the value of integral e raised to x sec x plus sec x tan x dx. So here, while saying the integration by parts, we had something right here. Okay, which I just, sorry, I missed. See, this is what we are going to use there. This is a question which is of the type integral e raised to x into e f of x plus f dash of x dx is equal to e raised to x f of x plus c. This is a standard answer. Okay, that is, what did we say? Integral of e raised to x into f of x plus f dash of x dx. If any function we see is of this type, then the answer is e raised to x into f of x plus c. That is, e raised to x is outside. See, now we are checking here. E raised to x is outside. Okay, good. And a function is there, sec x. Okay. And the next plus what? F dash of x. F dash of x means it's the differential. So this is the function and this is the differential of that function. See, isn't it of that type? E raised to x is there, sec x is there. So sec x is differential. Sec x tan x is also there. So this is of this one. Okay. E raised to x into f of x plus f dash of x. So we don't have to do any other complex parts or whatever. We got the answer e raised to x into sec x plus sec x tan x is of this type. So the answer for this is e raised to x into f of x. Here f of x is sec x plus c. So is that an option? Yeah. Option B is the correct answer. Okay, we just used this formula. This you have to know. Okay, and you have to identify that you have to use this. Okay, that comes only with practice. Okay, now if integral minus a to f of x a dx is equal to 0, then f of x must be, that we just did, right? Minus a to a, if it is 0, then it is an odd function. It is just defined in the that equations. So if it is an odd function, it is 0. If it is 0, it is an odd function. Okay, so odd function is the answer. The area bounded by the curve y equal to x square, the x-axis and the line x is equal to 1 and x equal to 2 is. So this is a problem from the applications chapter. So if we get a problem like this, you have first thing you have to do is to draw a graph. Okay, this graph. So I'm just going to draw the graph of this. So y is equal to x square. The whatever is there, y is equal to x square, x axis, the line x equal to 1 and x equal to 2. So x equal to 1, 2. So this is the line x equal to 1, correct? X equal to 1 is a line which is parallel to y axis. Okay. x equal to 1 is parallel to y-axis, and x equal to 2 is also parallel to y-axis, that passes through 2. So x equal to 1, this is x equal to 1 and this is x equal to 2. Now we want the x-axis. Yeah, x-axis is also bounded. Now y is equal to x square. Y is equal to x square, that is we want to find the values. We have going to draw the values. So for y is equal to x square, I'm going to find the values. Okay, we have x equal to 1. So when x is equal to 1, y is equal to y 1 square, that is y is equal to 1. When x equal to 2, y is equal to 2 square, that is 4. So that is what we are going to draw. Okay, it is 1 1 and 2 4 is the coordinates. So 1 1 means approximately like right here, and 2 4 is approximately right here. Okay, 1 2, okay, 1 2 3 and 4. Okay, so 1 1, this will be the graph. Now what? We want to find the area bounded by this curve. Okay, now this curve is there. Okay, bounded by this curve and x-axis and the line x equal to 1 and x equal to 2, which is the area that is completely bounded by all these lines. It is very clear from the image that this is the area, correct? This is the area that we want to find the area of. So if we want to find the area of this function, we have this, from this notes we have how to find the area of symbol curve. It is area is equal, if we are differentiating it with respect to x, it is integral a to b y dx. Okay, that's it. That's what we have to do. Integral area is equal to integral y dx. Okay, so integral a to b. So here dx, this a and b means the limits of x. We are with integrating it with respect to x. So the limits of x is what we have to write. So integral from where to where is x? X from 1 to 2. So the lower limit is 1 and upper limit is 2. And y, what is y here? Here it is given that y is equal to x square. So x square into dx. Now integrate, just integrate, that is x cube by 3 and applying the limits 1 to 2. So upper limit minus lower limit it is. So upper limit is 2. Okay. So 2 cube by 3 minus lower limit is 1. Just substituting the upper limit 2 in the value of x minus upper limit 1 in the value of x here. 1 cube by 3. That is 2 cube is 2 2s are 4 2s are 8 minus 1 by 3, which is 7 by 3. Okay, 7 by 3 is the answer. Option A, 7 by 3 is the answer. Okay, it is very simple. Okay, first thing you have to do is, since this is an MCQ question, no need to draw the graph. But if it comes in a 2 mark or 4 mark section, you must draw graph. There is mark for drawing graph. So an area is integral a to b mod y dx. Okay. Next, find the area of the region bounded by the curve y equal to cos x between x equal to 0 and x equal to pi. So this is also from that chapter. So first thing, draw the graph. For cos x equal to 0 and x equal to pi, correct? So when x is equal to 0, y is equal to cos 0. Cos 0 is 1. Then from x equal to pi is there, so I'm just finding one more middle value, that is pi by 2. So y is equal to cos pi by 2, that is 0. And x is equal to pi is there, so y is equal to cos pi, which is minus 1. Okay, so that's it. Now we are going to draw the graph of cos x. Okay, the curve cos x. So this is x-axis and y-axis. X and y-axis. So y is equal to cos x. When x is equal to 0, this is x. X values are 0, pi by 2, pi, 3 pi by 2, etc. And y values are 0, 1, 2, minus 1, minus 2. Then When x is equal to 0, cos is y is 1. Okay, x is equal to 0 and y is 1. That is here. We draw the point here. When x is equal to pi by 2, y is equal to 0. That is, it is here. When x is equal to pi, y is equal to minus 1. That is right here. Okay, minus 1. Okay, right here. So joining all these points, we get a curve like this. Okay, we just have to find a value between x equal to 0. X equal to 0 means x equal to 0 is y axis. Okay, x equal to 0 denote y axis. So y axis is one of the border of the area, and x equal to pi, that is, we are drawing a line parallel to y axis through pi. So, and this line and this curve, so the closed area is this much. Correct. So these are the two areas that this curve is covering. So now we want to find the area of this. So when we look here, in the previous question, we had everything in the first quadrant itself. But in this question, we have it some of in the first quadrant and some below the axis. So in such cases, what do we do? That we have written right here. See, handling negative and mixed regions. So we take, so for curve below the x-axis, we take the absolute value of the area. Since it is area, it doesn't actually matter. We are finding the area. Correct. So it doesn't matter if it is in up, upper portion of the axis or in the lower portion or the second quadrant or third quadrant. It doesn't matter. We just want the value. How much area is that? So what we going to do is we will be splitting it. Okay, that is from 0 to pi by 2 and from pi by 2 to pi. Okay, so area of the region, okay, area of the region is integral 0 to pi. We are actually doing 0 to pi. We are integrating 0 to pi y dx, that is integral 0 to pi cos x dx. So when we drew the graph, we had a separation. So we applied a property that we can separate it, right? 0 to pi by 2 cos x dx plus pi by 2 to pi mod cos x dx. Okay, good. Now cos x is, the integral of cos x is sin x. Applying the limit, that is 0 to pi by 2 plus here also sin x, that is also pi by 2 to pi. So sin pi by 2 minus sin 0 plus sin pi minus sin pi by 2. So sin pi by 2 is 1 minus sin 0 is 0 plus sin pi is minus 1 minus sin pi by 2 is 1. So the sin pi is 0. Okay. Minus sin pi by 2 is 1. So here we take the absolute value. Okay, absolute value of the second integral. So it is 1 plus absolute value of minus 1 is 1 itself. So 1 plus 1 is equal to 2. So that's why, so if we hadn't put this absolute value symbol, it would have been 1 minus 1 is equal to 0, which actually doesn't make sense. Correct. So this 0 means no area is there. But here definitely we can see some area. So that's why the rule is important. We have to split it as 0 to pi by 2 and pi by 2 to pi by 2 to pi, then putting the modulus. Okay, so we got the answer as 2. It is 2 square units area, correct? So 2 square units. Now evaluate integral minus pi by 2 to pi by 2, 3x cube plus tan raised to 5x plus sin raised to 7x plus 90x. So see, this is also a function that is of the form integral minus a to a f of x dx. So if we check all of these, 3x cube, okay, I'm just checking them separately. If any one of them, this is a combination of many functions. correct, of 1, 2, 3, 4 functions are there. So this is a combination of 4 functions. So I have to check if each and every one of that 4 function is odd or even. Okay, so that is, I'm taking f of x is equal to 3x cube. So for checking odd, if it is odd function, I want to take f of minus x, that is 3 into minus x cube. So minus x cube, okay, minus x cube. So minus x cube is, we can take the minus outside, so 3x cube is equal to minus f of x. Now another, the second one, g of x is equal to tan raised to 5x. Tan raised to 5x can be written as tan x raised to 5, correct? So g of minus x is equal to tan of minus x raised to 5, which is equal to minus tan x raised to 5, minus tan 5 raised to 5x, which is minus f of x. So here we got this, the first one was odd function, the second one was also odd function. I'm taking the third, g is over h. H of x is equal to sine raised to 7x. Okay, so h of minus x is sine raised to 7 of minus x, that is sine of minus x raised to 7, which is sine of minus x is minus sine x. So minus sine x raised to 7. This is also an odd function. Taking the next function, that is 9. Okay, 9 is a constant function, correct? That is not odd or even, just a constant function. So up to this, so I'm splitting this whole question. We had the question as minus pi by 2 to pi by 2, 3x 3x cube plus tan raised to 5x plus sine raised to 7x plus 9 dx. Okay, I'm separating them, that is integral minus pi by 2 to pi by 2, 3x cube plus tan raised to 5x plus sine raised to 7x dx. Okay, this is one function, plus again minus pi by 2 to pi by 2 9 dx. We can do like that. So now in this case, this is an odd function, this is a constant function. Okay, so integrating. So for odd function, the value is, the integral value for this case is 0, plus here it is 9 into integral of dx is x. So applying the upper limit and lower limit, minus pi by 2 to pi by 2, which is equal to 9 into pi by 2 minus pi by 2 upper limit. This minus is the upper limit minus lower limit. Okay, f of b minus f of a. So this is this minus, and this minus belongs to minus pi by 2. Okay, so that is 9 into pi by 2 minus pi by 2, that is pi by 2 plus pi by 2, which is pi by, sorry, 9 pi. Okay, so 9 pi is the answer. Okay, then the next question, evaluate I is equal to integral 3 to 8 root of 11 minus x by root x plus root of 11 minus x dx. So here, see, we have to use a property. See, I've mentioned a King's property. See, integral 0 to a f of x is equal to integral 0 to a f of a minus x dx. So integral 0 to a f of x is equal to integral 0 to a, the limit remains the same, f of a minus x dx. That is, we can change wherever x is there, we can write a minus x. Okay, wherever x is there, we can write a minus x. So how do we do that? We have this I is equal to right here. So I'm putting an equation number 1 for that. Now I am applying this rule. Okay, so I is equal to, I doesn't change, correct? So the limit doesn't change. So integral 3 to 8, f of x changes to f of a minus x. That is, we have x and then we can put a minus x. Oh, sorry. We had to use another property. It was another property. This was a special case of that property. Okay. Uh, This was the property that we had to use there. Okay, it is the limit is not 0 to a. If the limit was 0 to a, we could have used this. Okay, we had 3 to 8. 3 and 8 is both numbers. So a to b f of x was the one we had to use. Okay, integral a to b f of x dx is equal to integral a to b doesn't change, f of a plus b. A and b can get added, a plus b minus x dx. So we add a plus b and that is what we are substituting. So here we can write f of a plus b is 11, correct? 11 minus x dx. So this is f of x. So f of 11 minus x, okay, that is integral 3 to 8. 11 minus, see here already we have an 11 minus. Now in the place of x, I want to write 11 minus x, correct? F of x is equal to this quantity. So we want to find f of 11 minus x. So 11 we kept there, minus also kept there, then x. We change x to 11 minus x. So open a bracket, which is important. 11 minus x, okay, by root of x is changed to 11 minus x plus root of 11 minus x is changed to 11 minus x dx is equal to integral 3 to 8. Here 11, when we open the bracket, 11 and 11 will get cancelled. The remaining is only root x by here. This remains the same, 11 minus x plus here also 11 and 11 will get cancelled. The next is only root x. So this is equation number 2. Now what we are going to do is adding these equations. Okay, equation number 1 plus equation number 2. So on the left side it was I and I, correct? So left side becomes I plus I is equal to 2i. On the right side the limits were the same, and look, the denominator is also the same. Here the denominator is root x plus root 11 minus x. Here also the denominator is root x plus root 11 minus x. So denominator we can write a common denominator, root x plus root 11 minus x, and root 11 minus x. The numerators are added. We are adding, correct? So 11 minus x, root of 11 minus x plus here it is root x dx. Now see, the numerator and denominator are the same. So this whole will get cancelled. That will be equal to 1. So integral 3 to 8 dx is the remaining. So integral of dx is x, applying the limit 3 to 8. So 8 minus 3, upper limit minus lower limit, it gives us 5. So 5 is the answer. Okay. So what we have did right here is, when we observed, okay, we can add 8 plus 3, there is an 11 also right in here. So then no doubt you can now definitely apply this formula. Okay, integral a to b f of x dx can be changed to integral a to b f of a plus b minus x. So we had an f of x here, then we want to find here, and we what the next step is, we want to find what is f of a plus b minus x. Okay, a plus b here was 3 and 8, so 3 plus 8, that is 11. That means f of 11 minus x. So we just substituted into this equation and solved it. Okay, so 5 is the answer. The next question, evaluate I is equal to integral 2x by x square plus 1 into x square minus 4 dx. So this is a function where we can use the partial fractions method. So partial fraction method, I believe all of you must remember, correct? So here we can't actually directly, we can, but it will be more complicated. So here, as we have seen, all the denominators are linear pairs or linear factors, correct? But here both of them are quadratic factors. So I'm just applying a little bit of substitution also in there. See, so if I am substituting x square is equal to t, okay, substitution method I'm going to do, x square is equal to t. So what is the next step in substitution? Differentiate the substitution. Okay, so differential of x square is 2x. 2x dx is equal to differential of t is dt. So when we look at it, 2x dx is equal to dt. 2x dx is present in the question. X square is also present. That's why we took x square. So we substituted and we differentiated its differential, like 2x is present there. So I can definitely apply the substitution method. So substituting in the question. So I becomes integral 2x, the numerator is 2x dx. 2x dx becomes dt. So dt by x square becomes t. So t plus 1 into t minus 4. Okay, dx is also included in the dt. So no need to write that. So dt by integral t plus 1 into t minus 4. Now this is very simple. This is of the basic, the first type. Okay, this is of the first type. In the numerator there is a function that is here 1 x minus a into x minus b. Here it is t plus 1 into t minus 4. So how do we split it? So we are just taking the function only. After solving, simplifying, we will apply the integration again. So taking the function, that is 1 by t plus 1 into t minus 4, which is equal to a by t plus 1 plus b by t minus 4. Okay. So this is equal to, now what's the next step? We are taking the LCM, that is a into t minus 4 plus b into t plus 1 by t plus 1 into t minus 4. Since these are equal and the denominators are also equal, we get the numerator of this and of the right side are equal. So I'm going to equate numerators. So 1 is equal to, opening the bracket also, okay, at minus 4a plus bt plus 1, correct? So plus b. Okay, now equating the coefficients. Equating constants and coefficient of x. So what do we have? The constant terms. On the left side, the constant is 1, and on the right side, the constant is minus 4a plus b. Minus 4a plus b. And itself of x is, coefficients of x is, sorry, here we had t. We changed the function from x to t. So we are checking coefficient of t. So left side, the coefficient of t is 0. On the right side, the coefficient is a plus b. Okay, a plus b. So now we got two equations. We have to solve it somehow. Okay, b have the same coefficients here. So I'm subtracting these two equations. Okay, just applying the usual elimination method. This b and b will get cancelled. So minus 4a minus a, it is minus 5. Correct? Minus 5a. 1 minus 0 is 1. So we get a is equal to minus 1 by 5. Okay. Now substituting this minus 1 by 5 in some one of the equation, that is a plus b is equal to 0, and we now got minus 1 by 5 plus b is equal to 0. That means b is equal to 1 by 5. 0 minus will go to the right side, so it will come plus. So 1 by 5, b is equal to 1 by 5. So we got the value of a and b. So we are going to substitute here. So our function, our integrand will be changing to a by t plus 1. So here a was minus 1 by 5. So minus 1 by 5 into 1 by t plus 1 dt plus integral b by 1 by 5, that is 1 by 5 into denominator, it is 1 by t minus 4. 1 by t minus 4 dt, which is equal to, now integrating. So minus 1 by 5, I kept it there. The integral of 1 by t plus 1 is log t plus 1. Actually, how did we arrive at that log t plus 1? We know that it's just a substitution. Okay, I just substituted t plus 1 is equal to u. Another substitution inside a substitution. I know it's messy, but it's beautiful. So substitute t plus 1 is equal to u. So the differentiate, that is differential of t is 1. correct, 1 is 0, so it is 1 dt is equal to, for u is du, so dt is equal to du. So when I substitute here, it is 1 by u du. So for 1 by u du, it is integral is log u, correct. For 1 by x is log x, so 1 by u it is log u. So that's how we can write log u here, where u is t plus 1. Okay, log t plus 1. Actually, this can be very useful. You don't have to do this integration always, like the substitution always. In these type of cases, if you find that the base, okay, if you find that the denominator's differential is in the numerator, then you can apply. See here, the denominator was t plus 1, its differential is 1, that's in the denominator. Then you can directly say that log t plus 1 is the integral. Okay, plus in next taking value 1 by 5, integral of 1 minus t by 4, that is also happens there. The differential of t minus 4 is 1, that's in the numerator itself, so we can write it is log. Okay, the integral is log, or else you can go this way, substitute t minus 4 is equal to u and use the substitution method. There also you will get. Okay, if you have any doubt, just try that out. Okay, so t minus 4 plus c. Okay, so if you want, you can arrange it also, because both of these have the same coefficient, that is 1 by 5. So but this is plus 1 by 5 and this is minus 1 by 5. So using some of the log properties that we know, we can write log a minus log b is equal to log a by b. Okay, this is what we are going to apply here. So log a, the positive part is this, the second one. So log, on the numerator there comes t minus 4, and on the denominator is t plus 1 plus c. And we have to write what is t. What did we write for t? It is x square, correct. So 1 by 5 log mod x square minus 4 by x plus 1, x square plus 1 plus c is the answer. Okay, this was a pretty easy question, but we just first we made a substitution and then proceeded with the partial fraction method. Okay, now I is equal to integral tan x by sec x plus tan x dx. So this is the integration value we have to do. So here, do we have any option to separate it? That our ultimate goal is to separate this, split into some fractions or some functions which we know whose integral is, but we can't separate tan by sec or something else. So all we know is that tan x is sin x by cos x, sec x is 1 by cos x. So we are just going to substitute our knowledge in there. So we get I is equal to integral on tan x, I am writing sin x by cos x by sec x, I am writing 1 by cos x plus here it is 1, tan x is sin x by cos x dx is there. Okay, so here the denominator, both of the denominators are cos x and numerator also cos x. So that will get cancelled, correct. That is integral sin x by cos x is in the numerator and 1 plus sin x by cos x is in the denominator. So this end will get cancelled. So I get the remaining as sin x by 1 plus sin x dx. Okay, now how what we will be doing here is rationalizing or just multiplying the numerator and the denominator by this its conjugate. So for the conjugate of 1 plus sin x is 1 minus sin x. So we have sin x by 1 plus sin x. I am multiplying numerator and denominator by 1 minus sin x. Okay, 1 minus sin x. Let's see what do we get. It is integral opening sin x into 1 minus x is sin x into 1 is sin x minus sin square x by 1 plus sin x into 1 minus sin x. This it is of the form a plus b into a minus b. It is a square minus b square. So that is 1 square minus sin square x dx. Okay, so 1 minus sine square x is cos square x. So it is sin x minus sine square x dx by cos square x. Splitting, now I can split the integrals, that is integral sine by cos square x, that is we have sine by cos square x. So sine by cos square x is sine by cos x into 1 by cos x. So this sine and sine by cos x becomes tan x into one more 1 by cos x is pending there. So that will be 1 by cos x, that is sec x minus, now sine square x by cos square x. Sine square x by cos square x is tan square x. It is very clear, right? Tan square x. Now, do we know a function? Yeah, we know for function sec x tan x, the integral of sec x tan x is sec x. Okay, the differential of sec x is sec x tan x. So, the integral of sec x tan x is sec x minus tan squared x. For tan square, we don't know, but for sec square, we know. Can we turn tan square into sec square? Yes, we have a formula that 1 plus tan square x is equal to sec square x. So, tan square x is equal to sec square x minus 1. This we have learned in our class 10th. Okay, this is what we are going to apply. So, integral sec square x minus 1 dx. So, it is sec x minus integral of sec square x is tan x minus, okay, this minus will go out inside. So, minus and minus will get plus 1 dx. Integral of 1 dx is x plus c. So, this is the answer for this question.